I'm one of the co-organizers with Aaron O'Neill. Our sponsors tonight, obviously Yelp. Thank you very much. Let's give them a big round of applause for the facilities, pizza, beer, all that kind of good stuff. Also sponsoring tonight is IGN. IGN sponsors my time for organizing the events, putting things together. We host quite frequently as well. We are hiring for a mid-level DBA, so if you're interested in that position or know somebody for it, hit me up either after this or send me an email or something. Another of our sponsors is Continuant. They sponsor Aaron's time. They're also doing some other stuff for us, and they are looking for a QA engineer and a support engineer. So that's another good sponsor of ours. Someone from Yelp, there she is, has a quick announcement as well.
Thanks, guys. Hey, guys, welcome. My name is Amanda, and I work here on our systems requisitions at Yelp. We, too, surprise, surprise, are looking for a DBA. So if you're interested, my email is abell, A-B-E-L-L, @yelp.com. We're also hiring for a smattering of other systems positions, so just hit me up afterwards if you have questions. Also, Jenny is here. She's our DBA currently. She's awesome. She is a wealth of information, so please feel free to ask us questions. Thanks a lot. Enjoy.
And Percona is another one of our sponsors. They generally provide the food and all that kind of stuff. They gave us a few books to raffle off tonight. They are also hiring. Vadim is around here somewhere. Oh, there he is. So hit him up or check out their site, percona.com. I'm sure all their hiring information is there. If everyone could remember to turn off the volume on their cell phones and laptops. Take a few minutes to do that. You never want to be the one that has the ringing sound. The Wi-Fi tonight, it's on the Yelp Pub Wi-Fi network. The password is welcome to the party. It's all one word, lowercase. So if you need that to get on the Wi-Fi for something, welcome to the party. And I know you want to do something real quick.
Yet another job. Not looking strictly for DBAs, but sysadmins with some DBA foo. I really want to set up some tungsten replication and get into possibly Percona clustering. I would love to start doing that next week. If those things excite you, come talk to me. I work for Jawbone. We make physical things like this speaker. I'm going to try it in this room. I've never tried it in a... So that actually works pretty well. Being able to go to a store and see a product that you make is pretty cool. And I enjoy doing that, and we are firmware upgradable, so we have lots of online systems to keep track of all this, and we need to have a good MySQL foo to help put them all together. Thanks.
And then next month, we're looking to have, so Pinterest will be talking. We're looking to do that on July 25th. Date's still a little bit tentative. We should have that set tomorrow or the day after at the latest. But that should be a really good talk. Who's talking there? Marty and someone else whose name I can't remember. But they'll be talking next month, so that should be pretty good as well. And with that, I'm going to turn it over to Jeremy. He's going to give a talk about SQL and NoSQL at Craigslist. Thank you.
So thanks, everyone, for coming to the San Francisco MySQL Hiring Fest. Meetup. How many of you were at the Percona MySQL conference earlier this year? So just a few people. I wanted to just say again, thanks to the Percona folks that put that on. It was a great conference. The reason I mentioned that is I'm actually reusing slides from a talk I gave at that conference, but it looks like there's a little danger that most of you saw that. So I'll be giving a variation on that talk. I've done one of these meetups before, and it turned out to be more like 50-50 Q&A versus in presentation, and I think it worked out really well. So if you have questions, there should be ample time at the end that I can answer them, but if stuff comes up along the way and you don't understand something or you miss something or you feel like you need to ask right now, that's cool. Put your hand up and I can take questions. This is pretty loose, so we'll just go with whatever works. As you heard, I'm Jeremy Zawodny. I've been using MySQL in various capacities since the late 90s, both in my spare time for a number of years at Yahoo and now at Craigslist. And I worked on the first edition of the high-performance MySQL book, and I've written various MySQL tools over the years, too. So what I wanted to do is kind of give a talk about the mix of different data storage technologies we use at Craigslist, because when I look at our environment internally and I look at how things have evolved out in the open source world when it comes to data storage, it's a very different world than it was 6, 7, 8, 10 years ago. And we've got some experience with that, and I can talk about our experience, obviously take questions and learn from what you guys have done too. So one of the keynote presentations at that conference was Martin Mikos, who was the CEO of MySQL back when it was a separate company. And he was giving a talk one morning and kind of made the point that there's no stack anymore. Years ago, there was something we referred to as the LAMP stack, and a lot of us did development where you pretty much knew it was going to be Linux, Apache, MySQL, and then one of the P scripting languages. And I don't know how many of you are still using just the typical LAMP stack, but our environment looks nothing like that anymore. Hasn't looked like that for a long time, and I suspect that's true of a lot of you as well. That's great because there's a lot of great new technology out there. We can use a more appropriate tool for a lot of problems that we might have rather than banging everything with the MySQL hammer all the time. The challenge, of course, is that you've got so many options to choose from now that you have to figure out how to make that decision and what to look at and find out what works well for other people as well. So we've been through a little bit of that ourselves, and I'll talk about some of that. So instead of a stack, I think of it as a bag of cats. If you've ever heard the analogy herding cats, you probably understand why this makes some sense. What we use at Craigslist is a real mix of things. It's a bag of different things with different personalities that all fall in the sort of generic category of data storage technology. Everything from MySQL to typical memcache, which has been a standby for a long, long time, was probably the first thing that got added to the LAMP stack a long time ago. Newer technologies like Redis or MongoDB. We use Sphinx for full-text search. And we use the old standby. We use the file system for some stuff as well because it's particularly well-suited for some applications. But again, this picture has gotten more complex over the years, and I suspect it's going to probably get more complex yet before it starts to simplify again. So what we have to do when we're looking at solving a new problem or fixing a particular pain point is kind of just it's choosing the right tool for the job, and really what that means for us is kind of the right tool that's going to work in our environment. And there's a bunch of considerations that go along with that. Sort of from a technical point of view, you want to know about the performance and durability. We have to be able to fetch this many items per second, and we have to know that the data is going to persist across reboots, or it's not if we don't care about that. We want something with a friendly API on it. We're all kind of spoiled by having used SQL-like things, and there's the sort of joke going on. I was at the MongoDB conference recently, and there was a lot of joking there about the fact that they're slowly going to be building SQL interfaces on top of all the NoSQL engines. And I think there's some truth to that. You look at a lot of the query languages that other folks have built, and there's some subset of SQL either written in a JavaScript-looking thing or some other language. So it's funny, like everything old is new again. We're coming back to having sort of a more unified query language. We ourselves at Craigslist have built one as well for our own internal use to span data stores because nothing really existed. We have to look at the overall feature set, kind of what does this do, what box do we kind of put it into. Not everything in the world has to have full-text search and replication and high availability and all these things built in, but for different problems you need there's different criteria you're trying to satisfy. And then a big part of it is the last two items, which I think a lot of times go hand in hand, which are complexity and support. I'm a big fan of the Unix philosophy of having one tool that does primarily one thing well and then learning other tools that do other single things well, rather than trying to treat everything as if it's the same problem. I know for a long time, the history of the data storage at Craigslist reflects this fact, but a lot of shops start with MySQL and just put everything in there, put everything in there, put everything in there, even though it's not the most friendly thing. It can be kind of painful at times. And so, trying to figure out what the right balance of features and complexity versus really matching the tool to the job is going to be is tricky at times. And then support really comes down to a number of things. Some of that is the community that exists around a particular piece of technology. Sometimes it's just an active development community and an active user community. Sometimes it's a commercial company that's going to stand up and support this, so we can write a check to someone and they're going to promise to answer the phone in the middle of the night if it's broken. We do that in some cases. We'll buy a support agreement if it matters to us. And the other piece of that is how supportable it is, which is where the complexity comes in. We've got a pretty typical split of responsibilities. We've got a team of software engineers, and we've got a team of systems administrators that handles the day-to-day operations of the systems and making sure hosts are up and all that kind of stuff. But programmers, we don't carry pagers in the sense that we're not on call. The systems administrators are on call. So if a system is too complex to understand, they're going to have a hard time supporting it. If they don't understand something I deploy and can't figure it out in the middle of the night, they're going to call me. So I don't want the system to be too hard to manage either. So these are kind of some of the considerations that go into deciding what it is that we want to use. So with that, I'm going to jump into this sort of block diagram with boxes and arrows and talk about what some of our internal services look like and where the data goes. And I've got a couple slides like this. None of these are 100% accurate representative of how we do things exactly, but they're kind of a pretty accurate high-level picture just to give you a sense of what things look like on the inside for us. So I'll actually try standing in front of the screen here. So a typical request comes in from the browser, and this can be anything from someone trying to post a posting, run a search, or just browse the site. Oh, I should back up. How many of you don't know what Craigslist does? One guy over here. Okay, someone fill him in. I always forget to ask that. So requests come in from the outside. They hit a load balancer, and then get sent from there to what I'll call a caching proxy. I know a lot of folks in the old days, you might have used something like Squid. A lot of folks use tools like Nginx or other popular caching proxies that can do some of their own load balancing and things like that. We actually have our own homegrown solution for that. It's a proxy service that it's a Perl service written using ePOL, and it's paired with memcache instances for caching the actual pages that get sent out to the requesting user. We refer to it internally as MCP or memcache proxy, sort of a combination of those two. I'm going to set my beer down so I don't spill it. It works really well for our purposes. And the nice thing about this is the Perl piece of it that does all the proxying work is CPU intensive. It requires almost no memory, which means that we can use up most of the memory in the box for memcache. So pairing those two services together works really well. So there's a whole bank of those guys that sit out there waiting for requests to come in. They look at a bunch of rules that we have to decide where to fetch the content from if it's not in cache. If a particular item that the user is looking for is not cached, it hits one of the back-end web servers we'll refer to as an origin server. Our typical web infrastructure is Apache with mod Perl. There's typically memcache nodes running on the web servers as well, just because they've got extra memory available, so we add that to one of our other cache pools that I'll talk about. And then that web server is actually what's running the business logic that decides what to do based on the request. There's a pool of web servers that know how to handle simple reads, like I want to look at a posting, or I want to look at a list of postings that recently have appeared. There's another, we call those the readers. There's another bank of web servers we refer to as the writers that handle incoming requests that are writing information, things like creating a posting or updating a posting, that kind of thing, deleting a posting, looking at your account history. And then there's another bank of web servers that handle search. So we call those the search webs because that's what they do. In all cases, they're running a very similar stack. It's all Apache mod Perl code. There's memcache co-located on there, like I mentioned. And then depending on the type of request, that logic will fire off requests to other things. And this is where it gets interesting on the data storage side of things. We've got this async services group of machines that runs, and they, again, run this Perl ePOL daemon that has a bunch of service modules loaded into it that knows how to handle common requests. So you can think of this as kind of a worker pool that can handle CPU-intensive things or some shared logic that we can rely on some central pool for. So this particular service, sometimes one of the services it runs is referred to as our posting cache. So if a request comes in for a particular posting, you're looking at someone's bike that they're selling. The request flows all the way through to the web server. It realizes this is for a particular posting page. It may fire off a request here to our posting cache saying, I need posting ID 12345. And if it's cached in what we refer to as our posting cache, it just reads that out, sends it back, and then the web server takes care of formatting it, returning it to the proxy, which sends it to the user. Pretty straightforward. If it's not in cache, it actually needs to go and hit a database. You see we've got multiple levels of caching going on here. We try not to hit the databases with real-time traffic as much as we can because that gets expensive. I don't know what our cache hit rate is currently, but we try to keep the cache hit rate as high as we can because we're doing tens of thousands of requests per second otherwise. So that will, if it has to go hit MySQL, it's going to fall down to a bank of HA proxy servers, which is a relatively new addition in our infrastructure. That bank of HA proxy servers will decide which of the backend MySQL servers it needs to hit. This represents a sort of a cluster, not MySQL cluster, but just a group of MySQL servers that holds, yeah, slave pool, good name for it, all the live postings that are on Craigslist currently. And it'll percolate all the way back. Yeah?
What's HA proxy?
So HA proxy is a wonderful piece of technology that is often used as an HTTP proxy. So you can put it out front and it does the typical stuff you'd expect an HTTP proxy to be able to do. It can handle SSL, it can do lots of health checks on the backend web servers if you're using as a HTTP proxy. You can have all sorts of custom logic in there for balancing traffic based on server load or round robin and load balancing type stuff, yeah. We're actually using HA proxy for MySQL in sort of a dumb TCP level proxy. The only real smarts HA proxy has about MySQL is the fact that it can do a somewhat intelligent health check against MySQL. Rather than simply is port 3306 open, it knows how to connect to MySQL and start the authentication sequence as if it was a user connecting. So it assumes that if the HA proxy user that is configured, if you can attempt to authenticate as that user, it assumes the box is healthy. We could substitute our own health check in there, custom health check, but we haven't done that. Yeah.
Are the MySQL only read-only slaves?
The MySQL slaves are only read-only, that's right. And I'll talk a little bit more about this architecture when I drill down into that. So that all percolates back up. If the request that came in was destined to one of our search web clusters, it's likely going to fall through and hit one of our Sphinx clusters to run a full text search. That full text search simply returns back a list of posting IDs, which then can be asked from this service, which has our posting cache and can send the actual postings back to format the data as necessary. If that request that came in was a user logging into their account homepage, looking at some old postings they had from a year or two ago, and maybe they want to repost one of them. You listed a particular job opening for your company. The person left. You want to pull that job posting back up, edit it, and repost it. That can come out of what's called our archive postings, which live in MongoDB. And I'll talk more about that as well. Yes? Do we use persistent connections between our web server and HA proxy? No, we don't. Or we don't use persistent connections between the web server and HA proxy or this service and HA proxy, really. There's a reason for that that's mostly historical, and the reason is that if you count up the number of web servers and the number of Apache processors running on the web servers, if they all held persistent connections open at the time, back then it was to MySQL, but now to HA proxy, it's a large number of connections. I've not seen much nowadays that tells me HA proxy or MySQL couldn't handle it, but historically that had been a problem. So all of our code is kind of designed with the, if you've got a query, it's like connect, query, disconnect, and it just does that over and over. In practice, it's not been a problem for us, but we could probably go and put persistent connections in and not notice any real difference either. Since all the stuff is internal, all in the same data center, the performance impact is negligible. Was there another hand I saw? Okay. Okay. So there's another request flow that can happen as well. So if you're viewing a posting on Craigslist, oftentimes there will be images associated with it, especially people selling cars or putting puppies up for adoption or whatever it is they're doing. And so what happens in that case is, again, an image request comes in from the browser, hits the load balancer, again goes to that MCP, that caching proxy, but that then turns around and talks to our image storage devices, which is just a bank of commodity servers with lots of disk space on them. These guys run web servers as well, Apache and Mod Perl, but the data storage is local on these guys. It's basically just XFS with just a bunch of disks in there. No fancy RAID, none of that kind of stuff. And the reason there's no fancy RAID is because there's redundancy built into this cluster where the same image lives on multiple machines, kind of like the duplication that happens in HDFS with Hadoop, for example.
NFS mounts on the XFS or no?
No NFS mounts. NFS bad. Question back there. What mechanism takes care of the replication between the image hosts? I am going to confess ignorance on this. I don't know the details of our image system really well, so I can't go into that level of detail. Other questions? Yeah.
You have the Sphinx for the previous slide.
Yes.
Is it standalone or the MySQL agent one?
We're using standalone Sphinx, and I'll talk more about the details in a couple slides too.
And why you guys are archiving MongoDB versus leaving it in Sphinx?
I'll talk about that too. Okay, I'll move along. So you've seen a couple request flows just to get a picture of how things work. So this is kind of the big map. The big inventory of what we have. And I broke it down by technology or by service, and then kind of chunked in the little bits that describe the data that's stored in these different data stores. And I know you can read, but I'll just go through it real quick anyway and try to answer any questions that come up. MongoDB is all of our archive postings. I labeled old postings here because I didn't want to reformat the whole damn slide. And then there's some email metadata we use in like this transient MongoDB store we've been experimenting with. But that's a relatively new addition. MySQL is kind of our bread and butter. It's been around the longest. It's got most of our data in there. All the postings that come into Craigslist live in MySQL for some amount of time when they come in. All of our user database, our user data records are in the users database, which is a separate MySQL instance. All of our finance data lives in MySQL. We've got some miscellaneous metadata that's going to go away soon, some stats data that we keep in a stats database. We've got some monitoring data that we keep historical monitoring information in, also kept in MySQL. We also are abusing MySQL as a work queue for some stuff, so that lives in there as well. File system is primarily used for two types of storage that we do. One is the images I talked about already, and the other is just logs. I know some people log to databases or things like that. We just log to syslog over the network to some log host and aggregate logs that way. Question? Oh, we don't use any CDNs. We serve all of our own assets off our own servers. So it's, I don't know what's with the big bunny in the back of the room. I'm assuming there's a good story there, though. So the question was, are we serving the assets for each region directly off these web servers? Yeah, we basically, Craigslist exists in 2 data centers in the United States. All data is duplicated in both data centers. And we serve all the HTML, all the JavaScript, all the images off of servers in both of those data centers. They all run through that same caching layer that you saw on the earlier slide. So most of the stuff, whether it's a posting page or an image or a piece of JavaScript or a piece of CSS, is all going to be typically sitting in cache most of the time. And we can do that fast enough that there's never been a real benefit to using a CDN.
So when you roll out a new service in a different country, would you basically set up a server in the country for
Yeah, so the question is, if we were to roll out a new country, would we set up servers in that country and for rolling out assets? The answer is today, no. We're only in 2 data centers, and they're both in the US. We've internally talked about the idea of setting up kind of like single rack instances in other locations around the country, around the world, so we could put at least the caching part of that infrastructure, the load balancers and the cache out there, and then they could reach back to get the assets out of our central repositories. We haven't done it yet. It's one of those optimizations we'll probably get to one of these days, but one of the complaints we're least likely to see at Craigslist is speed, because our pages tend to be pretty fast anyway. Yes?
Do you maintain postings forever, like history, or is there a cutoff?
Do we maintain postings forever, or is there a cutoff? I'll answer that soon. Question?
What's the connection between the 2 data centers?
Connection between the 2 data centers is multiple gigabit dedicated connections that are private to our data centers. I don't remember how many, but I believe there's more than 1.
You guys own your data centers?
We lease space in 2 different data centers. We own the equipment. We don't own the data center space itself. But yeah, I have this on another slide too, but I'll just mention it since it's likely to come up. We don't do any virtualization. We don't do any EC2. We run on our own metal, and we buy our own servers and provision our own stuff. Yeah. Where are the data centers? One is in San Francisco, and the other one is in It's Scottsdale, Arizona. Yeah. How are we keeping the multiple databases in sync when we have an update? I think I'll answer that question in more detail, but it's basic MySQL replication. Yes? So the question is, are both data centers active at the same time, or are we working primarily out of one? Sort of yes to both. Historically, one was active and the other was undergoing some form of maintenance or upgrade or changes or whatnot. More recently, we've been in a state where one data center is active, all the masters live there, all the writes go there, but we've been able to serve some assets out of both data centers, like images or things like that. We want to move to a world where we can run live out of both data centers, full functionality, and ultimately end data centers. Obviously, that's a harder problem, so we've not quite tackled that yet. We've kind of been playing this leapfrog game for several years where we get into a data center, we're happy with it, and then we outgrow the space. So we get bigger space in another data center, build that out, move all the traffic there, and then go re-upgrade the old one and kind of keep shoveling back and forth. But the nice thing is with all the consolidation we're able to do now with the multi-core servers and much better hardware is we're not physically growing data center space quite as much as I think happened in the past. Yes?
What's the ratio of reads to writes?
The ratio of reads to writes on the database side? Oh, God, that's a darn good question. It varies by cluster, and I'd actually have to log in and look. It's been so long since I checked. It would be ridiculously high reads to a small number of writes if we didn't have all those caches in place. It's still far more reads than writes because not everything hits cache, obviously. I mean, typically everything that's written is read at least a couple times. But it's a lot closer to being balanced than it would be without the caches. Yes?
So with your two data centers, can you talk about disaster recovery or how you use those?
So what we do for disaster recovery, since we have two data centers, so one of the goals is to try to make sure every service is capable of running in both data centers at a given moment if we needed to, which means we keep the data up to date in both data centers, which means we're monitoring both data centers with typically the same sorts of thresholds for alerts. There's typically sufficient hardware in either data center to take the load. We may not handle it as gracefully, but we should be able to at least serve traffic. Today it would require some manual intervention if a service failed to bring it up or to make the one in the other data center active. But we're typically provisioned out on the equipment side, and the data is available there. So it's really just a kind of an admin, switch flipping kind of operation typically. Then oh my God, everyone panic and get involved. We reserve that for other things. Yes. The latency between the two data centers varies. We actually, I forgot to mention this earlier, we have two different providers giving us back-end circuits between the two. One of them is slightly higher latency but very reliable. The other one is lower latency but not quite as reliable. So it depends which one we're on, but it's on the order of 20 to 40 milliseconds typically. Okay, let me finish up with this real quick then. So we have Sphinx that we use for full text search, which I think I talk more about later. We index all the live postings on the site. We index archive postings. We index our forums, which a lot of people don't realize Craigslist has discussion forums, but we've got discussion forums that get used. And we have some internal stuff that we use too. So there are searches that we're able to perform internally that outsiders can't perform. We've got Sphinx clusters set up for that. Redis clusters in both data centers for storing counters of various things, managing a couple of work queues we have, storing temporary blobs of stuff we use for analysis. Lots of lists and sets of things that we use for analysis of what's going on in the site, and a little bit of monitoring data that gets reported for sort of very micro isolated things. And then memcache we use for some basic counter functionality, storing cached postings, cached objects, typically serialized Perl, and other types of blobs that need to be cached for typically delivery to the end user from the caching proxy or feeding to the web server that can format or turn it into something that can be delivered to the user. So more MySQL specific stuff, yes? Why do we have Redis and Memcache? That's a good question. A lot of people look at the two of them at the high level and say they're pretty much the same. which is true. They can both be used as caches. They can both store key value pairs. Redis kind of steps away from that in that it has more sophisticated data structures like sets and lists and sorted sets, so you can perform lots of server-side operations on that data very quickly. So it's much, much easier to do some things. If you want to do them in memcache, the operation would be fetch the blob of data, pull it back, manipulate it, store it back there, and hope no one else changed it in the meantime. But with a Redis instance, you can basically just tell the server, hey, take the list at this key, append this value. Or take the set at this particular key and remove these two values or something like that. So it's used when you want to take, I think of it as programming in a scripting language like Perl or Python or Ruby. You get used to having all these first-class data structures built in, right? We're used to having scalar values, we're used to having lists, we're used to having sets, we're used to having hashes. They're called slightly different things in different languages, but fundamentally we all use the same things. If you can basically pick those up out of your program and put them on a server where they're a shared resource, and then multiple clients can interact with that, it's like having shared access to these data structures. So it's incredibly useful for some types of work that we do. Yeah?
So why not only Redis?
Why not only Redis? Well, Memcache has been around a lot longer. It's been in our infrastructure for years before Redis existed. We could probably just use it and go rip out Memcache, but that'd be a bunch of busy work at this point. So no reason.
And you have memcache clusters and memcache running on the Apache server.
We do have Memcache running on the Apache servers. That's right. Yep.
What's the difference between what they cache?
The difference between what they cache. So we've got Memcache running on a bunch of different nodes in our infrastructure, and the caches are logically divided up into different types of data. So the ones running in the proxies, for example, hold data that's likely to be read from a proxy and sent back out over the wire to the end user. So it's formatted web pages that are either a posting or a search result or a set of listings chronologically on the site. The stuff farther back in the infrastructure is typically our posting cache, which is the sort of serialized posting object suitable for consumption by a Perl script, or it's some transient data that we have. Things like the typical problem of having to store a user session. You need to put a session somewhere so that when the user comes back in a different web server, we can still find their data. That goes into memcache as well. So we kind of use it in several different clusters for transient data like sessions. We use it for data, like I mentioned earlier, the serialized posting objects, and then there's other bits of things. We use it for counters for some things and rate limiting on other things and a bunch of miscellaneous bits. So it's just carved up based on kind of what we need. Yes?
When I create a new posting on Craigslist, is that cached initially and then ultimately sent to MySQL?
When you create a new posting on Craigslist, is it cached initially and then sent to MySQL?
Or does it get stored immediately?
In our current implementation, it gets stored almost immediately in MySQL. We have some notion of eventually caching that in memcache until you've finished the posting, because it's kind of a multi-step process when you're creating a posting. And then once you've finished the posting, then it gets written to the database in its like one true state. That's a project that'll probably happen in the next year or two, probably. Yes?
How do you handle cache expiration? You just have TTLs and everything that expires and you see it.
The question is how do we handle cache expiration? And the generic answer is that varies based on the data type, but some of the data has explicit TTLs because we know we want to set things for only a certain amount of time. A good example is that we'll put a TTL on a posting or a TTL on a search result, for example. And then other stuff just gets LRU'd out. So things like we've got this transient object storage pool of memcache servers. And stuff in there, it's like, we don't care too much about. It's data that's in there, and we know it's going to stick around for a while because of the cluster size, but we don't care to explicitly set a time for it, so it just gets LRU'd out eventually.
If I was going on the market posting this spam or abuse of some sort,
Mm-hmm.
how does that then reflect itself if it's going to be cached on the web service?
So the question is, if you come to Craigslist and flag a posting as spam or abusive or something, how does that get reflected? The long version is I could draw out a big diagram and show you, sort of. The short version is that what happens is if that action triggers a change in the posting status, some processing on the back end kicks in to change the status of that posting, and then when that happens, it pokes the cache to say delete this, so that the next request comes in, causes the cache to be reread, and in it comes. Okay, so you've probably all read this while I've been yammering up here, but How we use MySQL at Craigslist is a combination of sort of vertical and horizontal partitioning. So we do sort of vertical partitioning into different clusters, like I talked about. We've got one for classifieds, which is the postings, one for users, which we call our auth database, one for finance, one for whatever. You know, there's a list of about 6 of those. And then we sub-partition within a cluster into different roles, and I'll talk about that. I've got a diagram of that on the next slide. But the basic idea is we've got this notion that, and some of this is historical, but you generally know when you're writing code that some queries are lightweight and some are heavyweight, right? If I'm going to select an item by posting ID, which is our primary key, it's a fast operation. That's a lightweight query. But if I want to find all postings that have changed in the last 20 minutes, that's a heavyweight query, because that's probably going to return several thousand rows. It's going to use a different index that may or may not be hot. So that's a heavier weight query. So we kind of separate our slaves, or actually all the machines in a cluster, into different roles based on the types of queries we want to send at them. So there's the master, which of course takes writes, and generally only writes. There are very few cases where we have to read from the master in order to ensure some sort of guarantee. But then we have some that we call the read slaves, the long read slaves, the dumper, and the thrash, and I'll go into this in the next page and talk more about that. Nowadays, we have lots of SSD storage in our database clusters, almost exclusively Fusion IO. When I started Craigslist, it was all RAID 10, RAID 5, RAID 10 arrays with typical spinning disks, and you got more than 2,000 IOPS out of a machine, and you were really happy. Nowadays we're well past that, and we ditched the last of our spinning disks sometime last year, I think it was. I actually did a talk at I think it was one of the Percona conferences like a year or so ago here in San Francisco. It was a smaller event. And I did talk about how we were able to remove like 17 MySQL servers from our infrastructure and speed up requests as a result. And it's because we replaced all these old spinning disk machines with solid state. So most of our performance problems kind of went out the window when we did that. In a way, it's kind of like buying your way out of the problem, but it makes sense. It makes sense because the reality is the machines are so powerful nowadays that you've got all the CPU power and you can't do squat with it if the disk can't keep up anyway. So
At the time you were using flash cache, so is that also gone? You have no right now?
we're not using flash cache. No. I've looked at it. I know one of the guys who worked on it, but we're not using it currently. It's interesting stuff, though. I could see if we had a much larger data footprint that we had to keep active, we might be using flash cache because it would give us that sort of 3-tiered approach rather than just everything on flash. So what else? Oh, and we've been trying to reduce our administrative workload in the last couple of years by automating as many tasks as we can. The biggest of which nowadays is either recloning slaves if a slave blows up, or swapping a new machine in for a master if a master dies, and these are becoming less problematic now too. Question there?
So you don't use spinning disk even for like XFS image repository?
This is MySQL specific. So we use solid state for the MySQL stuff. In the case of our image servers, we're using spinning disks for that. Yep.
And how big is your data set for MySQL?
How big is the data set for MySQL? We actually have a new employee who asked me this earlier today, and I'm just trying to come up with numbers. The different clusters are different sizes. The biggest one is something in the order of 600 gigs. It varies between, I think, 450 and 700, depending on Innodb fragmentation. The largest table in that database is actually, we're using Innodb compression on as well, so it would actually be quite a bit bigger if we weren't. So that's been quite useful as well. Yes?
What kind of reliability are you getting out of the Fusion IO cards? Do you run them in array configuration?
So the question is, what kind of reliability have we seen out of Fusion IO, and do we run them in RAID? Yes, we run them in RAID 0, in the reliability. We want space. Reliability has been really good. Actually, we've been real happy with them. We deployed them in an environment very slowly and deliberately, because with any new technology, you're like, do I want to trust this to my data on this, right? And the last machines in our database clusters to get the Fusion IO drives were the masters. We tested it on the least important slaves, and then the more important slaves, and then the read slaves, and then Eventually the day came where it's just like, okay, the slaves are way more powerful than the master, it's time to upgrade. And it's worked out really well. You know, it was one of those things where we were careful about it, we didn't rush into it, but the reliability has been really good. It's, you know, a friend of mine at another large internet company who was using the same technology told me that the interesting thing about the Fusion IO stuff is it seemed to be really reliable. If you've got a bad card, you'll know in the first week it's online. And we've had, I think, maybe 1 or 2 bad cards, and you send it back and they send you a new one. But like once things have really, you know, kind of once the cards are burned in, they seem to just work. No, I'm probably, you know, tempting fate, and one of our boxes is going to crash right now since I said that, but that's just our general experience so far. Way in the back. I'll talk about those. I got a whole slide that illustrates that shortly. Yeah. Yes.
You mentioned pulling stuff by primary key. Are you guys using handler socket?
We are
not. Why not?
We are not using handler socket. Why not? We just don't need it. I mean, there's been, you know, we would, if we had a performance problem that I thought it would solve, I would try it. It's you know, it's cool technology, but it's just like we don't really need to go to that level right now. Sending a select query in is good enough. Yes.
Can you say which flavor of MySQL you're using, or if you're using patch sets?
We are. What flavor of MySQL are we using? We are using 5.5 something. One of the milestone releases. I think it was 3. So we are on 5.5. It's not the latest release. It's not because we don't trust the newer code. It's just because it takes time to do an upgrade and priorities shift around. But we're pretty happy with how it works so far. We made the jump to 5.5 quite a while ago for a number of reasons, part of which was we were going to solid state storage, and we wanted to be able to tune some of the knobs that we could tune in 5.5. So, yes?
You said you use Innodb compression.
Yes, we use Innodb compression.
Can you talk more about the testing process you went through before you trusted that technology?
So the testing process, so the question is, how did we test the Innodb compression before we used it widely? The answer is we did a couple types of testing on it. One is we had to test to see which compression level made the most sense for us. We're just using the lowest level, like the 2-to-1 compression, and that's partly because when we originally set up compression, we were still using boxes with all spinny disks on them. So we were concerned about any extra overhead we were going to add in terms of fragmentation or anything else. So we did some testing with the different compression level settings, and then after we sort of settled in on a sweet spot and figured out what we liked, we then deployed it on one slave and let it run for a while. Because you can make the change on a slave and let it participate just like any other host in the pool, and it runs just fine. We watched the numbers on it. We watched all of the metrics we had. You know, are we doing more IOPS? Is that box falling behind at all? Is it doing a lot more CPU work? That kind of stuff. The bottom line was, at least from a CPU point of view, it didn't matter. We were barely using 1 core as it was, so the other 3 were bored anyway. So that wasn't a problem, and literally it was just a case of testing it long enough. And I don't remember how many weeks it was that we ran that way, but we made the change, and you know, we'd make it on one slave, let it run for a while. We were happy with it, so we'd shut down a different slave, clone the one with compression over to the one without, and then we had 2 slaves, and then we got to repeat that process until it bubbled all the way up. And then eventually we'd just like promote a slave to master and flip the 2 to get the master actually, the old master then running with compression.
What kind of compression ratio?
We're seeing 2-to-1, which is sort of the conservative, you know, it works well for what we're doing. We might be able to squeeze more out of it now. But you know, we're primarily compressing the posting body, so it's the actual ad text that people type on Craigslist. What are we paying in terms of penalty? In what sense?
I mean, are you seeing any slowdown because of the compression?
No, the question is, are we seeing a real slowdown, any slowdown because of the compression? And if we had any, it was not really measurable in our workload. I'm sure I could construct a benchmark that would find a slowdown, but for the workload we have, it doesn't make a difference. And at the time when we were around spinny disks, the reduction in footprint and better use of the OS cache was such a huge win anyway, or I should say, being able to fit more into the Innodb buffer pool in memory was a huge win anyway, because we were on disk where we couldn't do more than about 2,000 IOPS anyway. So that was a big win for us. We we saw a performance improvement. I wouldn't, yeah, it's hard to call it performance. We definitely saw a better cache rate. Our workload is such that sometimes those things aren't as apparent as they should be because you might look for it in one place and it appears somewhere else. But yeah, we definitely saw things improve.
How big of a buffer pool are you using?
The buffer pool, how big a buffer pool are we using? At the time we did that, we were on boxes with 32 gigs of RAM and we had 20 gig buffer pool. Nowadays we're running on boxes with 72 gigs of RAM and we have, oh God, it's either 48 or 60 gigs. I'm trying to remember what we set up. We originally tested with 48 and we might have gone to 60. I don't remember if we made that change yet. Yes?
What character set are you using and how long would it take you to restore your backup of the archive?
Of the archive?
Yes.
Okay, so what character set are we using? In the MySQL database, we're still using Latin 1. UTF-8 is kind of a pain for us still. A lot of our code is very, very old and needs to be updated. To restore, so the question is, how long would it take to restore from a backup of our archive, like all the old postings from Craigslist? The answer today is it would take infinitely long because we don't have a backup. But we have a duplicate of it in a remote data center. So the real answer is we would just clone it from the remote data center, and it would take however long it takes to push a few terabytes across a couple gigabit links. So we have a backup strategy for the archive. We just haven't implemented it yet. All right, so let me move on here. What else can I say? Some of these questions are already coming up. So we're running 5.5.x. We're hoping to move to 5.6 at some point. The global transaction ID and crash safe replication is really, really cool stuff that would make a bunch of our pain go away. We have not had a chance to test it yet, but I look forward to doing that. We're using Innodb almost everywhere. Actually, we stomped out the last bit of my ISAM about 2-3 weeks ago, and it was a very glorious day. Yeah, repair table sucks. If anyone's curious, we were holding on to it because of full text search in one old system, and we got rid of that finally. We're using, like I said, Innodb compression, large buffer pools. Yeah, 48 gig is what I put in here. That's probably what we're currently at. We've talked about moving up to 60. And you saw the HA proxy stuff already. So someone asked about this sort of segmentation we do of the hosts in a given database cluster. So this is kind of a visual representation with color. So the idea is, like I said, we've got a group of slaves that we call the read slaves that get the simple queries, primary key, or very small record set fetches. Then we've got a different group of slaves we call the long readers that typically are getting larger, usually systems that are going to do large batches that get pulled in for updating, like rebuilding search indexes or things like that. We'll pull from these guys. We refer to the thrash box in a given database cluster. It's the machine that gets no user-facing traffic, is not really used for anything production quality, but it's monitored as if it was. This is where we send all our internal ad hoc queries, or if you need to do a select count star and actually do a full table scan for some reason, you send it there. Because that box is slightly different alerting thresholds on its behindness and things like that. Yes?
Can you put the last slide up just for a second?
Oh, previous slide? Sure. These are online also, by the way, I should say, because I gave this talk at the Percona conference, but feel free to photograph too. And then the final one that serves no actual traffic in our environment is called the dumper. We use it for backups. So there is a slave that exists for the sole purpose of being able to run backups. And before people put hands up, how do we back up? I'll answer that question, because I'm sure you're wondering. We are using extra backup. Thank you, Percona. So we're doing hot backups of Innodb. And we do them every 24 hours in a given data center, and we offset the two data centers by 12 hours, so we've got backups that are at most 12 hours old. Okay, now who's got a hand? Ah, still.
So, agent proxy is actually monitoring the traffic to the different server. How is that being done in code?
So yeah, this is fun. I just explained this to a new employee today too. I can't go into that level of detail, but the question is, how does HA proxy get the connection from the client to the right one of these guys? The answer is that the client requests what we refer to as a database handle by name. We've got these name handles that the names look a lot like these names you see up here. And in the code, that particular handle maps to an IP address that in the HA proxy config is mapped to a different set of servers internally. So you can imagine these boxes having lots of IP addresses sitting on them. And depending which one it comes in on, we can send it to the right group of servers. So it's sort of like a virtual server, sort of like a IP-based virtual server sort of thing for routing database requests. Yes.
What's your replication setup look like, and how do you guys deal with schema changes? You mentioned that you had a 600 gigabyte table. How do you modify it?
Okay. So the questions are, what does our replication look like, and how do we deal with schema changes, especially with a 600 gig data footprint? Replication is classic master-slave within a given data center. You've got one master, multiple slaves, and the master sits behind this right handle, but these are all roughly equivalent slaves. They'll connect to the master and do their thing just like you'd expect in replication. In the remote data center, we've got the exact same thing. The only difference is that in the remote data center, master there is actually a slave of the real master in the live data center. So we refer to that as the middle master, because it is a master, but it's in the middle of the real master and the ultimate slaves in that remote data center.
No multiple masters?
No multiple masters, that's right. Yeah, we haven't gone that way yet. Yes?
You mentioned the last slide that you've been hanging on to MyISAM for the full text search, but now you've moved to Innodb. I'm just wondering what your current solution is for the full text search.
We are using Sphinx for full text search. Yes?
Can you talk about Sphinx versus Lucene and why you went with Sphinx?
Sphinx versus Lucene and why we went with Sphinx? Sure. Let me peek ahead and see if I have a slide on this. I think I do. I'll get to that. If I don't remember to mention Lucene, remind me though. Yes?
How do you monitor that a particular request goes to the right type of database here in your cluster, and how do you actually switch it to reroute it?
How do we monitor that a particular database request goes to the right type of cluster member? It's up to the programmer. So it's up to me as a developer to know that the type of query I'm running belongs running on a long read versus a read versus something else. The reality is that most of our time is not generating lots of new code, writing lots of new database queries. So the code base that's querying MySQL is relatively static. We do have an internal code review process. So if someone was to paste a link in and say, hey, review this diff, one of us would probably look at it and be like, you may not want to send that query there. And then they can go in and fix it. Other than that, the HE proxy config is pretty hard-coded, so if they put the right handle in there, it's going to go to the right place. Yes?
Just to get an idea of how much the scroll is.
Sure.
Can you say, obviously there is one write, one write master, and then one read. How many reads, long reads, and servers do you have?
So the question kind of is how many machines are in these clusters, typically speaking. I think it's a minimum of 5, roughly. We sometimes more. So we always have one master, right? We typically have at least, at a minimum, we'll have 2 reads, typically 3, because the idea is if one face plants, you need to bring it back up, and you may need to clone it from another, or restore from backup, depending on what the situation is. So you may need to knock another one down. There's typically 1 to 2 long reads. There's always a dumper. This thrash one may or may not exist. Not all of our builds have that. But this is sort of a generic kind of what it looks like. For our postings database, the live database of all the Craigslist postings, this is pretty accurate. There are other clusters that are a little smaller in terms of number of machines. Yes?
What's your
Our process
process for promoting a new master?
for promoting a new master. There's 2 answers to that. One answer is that we have a step-by-step process documented in our internal wiki that one of our systems people follows in order to promote a new master, which involves, well, it depends why we're promoting a new master. If we're promoting a new master because the master failed and we need to find the most up-to-date slave and promote it and do that whole thing. If we're promoting a new master as part of the planned maintenance, it's very easy because we've got switches that we can flip to shut down all writes. We verify that all writes are stopped, and then we can pretty much just pick a slave, update all the relevant entries in the config that says that's the new master, point all the slaves at it, and then we're good to go. A little while ago, maybe it was last year, I wrote a tool called MySQL Nominate Master that was to be run in the event that a master dies. It can quickly look at all the available servers, survey the landscape, recommend which machines are eligible for promotion. Like if you've got 2 or 3 that are all at the same bin log position, they were the 3 most up to date because they're identical. You can choose one. It'll promote it to master. It'll promote the others. It'll say these others need to be read slaves. Here's a list of other boxes that need to be recloned or reconfigured somehow because they're out of date. And it will do it'll do a bunch of that and then tell the systems administrators what other work needs to be done manually. We have not yet run that in production, so I don't know if it works. I think it does. I've had a few people review it, but we've never had to try it. Or I should say, we've never been in a position to try it where someone remembered that it existed and thought to try it, which may be to my benefit. I don't know. Yes.
So as a follow-up to that, when you promote a new master, do you ever need to restart the application stack because the attribute and other services talk together?
Okay, so when we promote a new master, do we need to restart the application stack? Typically, no. For the most purposes, now we're in a position that we've got really two sets of controls at play here. One is the fact that everything's going through HA proxy. We can push out a new HA proxy config, restart the HA proxies, and then we'll know that the requests are going to go to the right places. Like, we're not going to be sending a bunch of read requests to the machine that's the new master. We also have a set of modes that we can put the website into. And we express them as just simple strings. So we've got a mode that we refer to as DB read-only, which means that the databases are all in read-only mode. You cannot send writes into any of the masters. And all of our spaghetti code that talks to the database at least uses a common low-level library for talking to MySQL. So it can check queries coming in. If we're in read-only mode, it will refuse to run a query. That's one thing we did particularly well, actually. So the applications are somewhat aware of this particular thing, and they're actually becoming more aware of this because we're improving the way this works as of just a couple weeks ago. So we can go into read-only mode. We can go into what we call DB no access mode, which means you can't write, you can't read. The database is off limits. It's rare that we have to do that, but we can do it if we need to. And we've got a couple other switches we can throw. So if we're going to take the finance system offline, we could go into a mode where we only allow free postings but no paid postings, because we don't know how to take money when the finance system's down anyway. So we've got a couple toggles like that. So between those and being able to proactively update the HA proxy config, we're actually in decent shape when it comes to not having to restart everything. It used to be that every time a DB, when HA proxy didn't exist, the information about this mapping used to be stored elsewhere being DNS, which is a bad place to do it. And worse yet, the clients only did the DNS resolution at startup time. So you had to actually go and actually restart all the services every time one of those things changed. It was painful. So HA proxy was a big help in getting rid of that for the most part. Yes? So the question is, are these boxes all the same from a hardware point of view, or are they different? The answer is today, for the most part, they're all the same. One of the goals in our infrastructure is to try to, for the most part, treat machines in a given pool as interchangeable pieces. So if one gets shot, replace it with another. Don't worry about the specific config because it's the same. We know it's a database class machine. Now, there are always differences, like if we're rolling in new hardware and rolling out old hardware, there are transition times and things like that where there's a mix. But generally speaking, our goal is to keep things the same, keep them simple. Yes?
Do you tweak the weights between the different nodes to experiment with profiling of different loads?
Do we tweak the weights between the different nodes? So we can actually adjust weights in HA proxy. And the answer is today we don't, but we've got the option of doing that. We've got tools to do that, a tool to do that on the fly if we want to. One use of that could be we're going to bring a new slave into the pool, and we want to sort of warm the cache without pummeling it with requests. So we could start out with a very low weight so it gets a trickle of queries and warm it up. We haven't done that yet, but we could. Yes?
Is practical advice, if your master fails, how long do you spend trying to recover the master versus promoting a slave?
So if the master fails, how long do we spend trying to recover the master versus promoting a slave? The answer is 0 time. The master face plans, we pick up a slave, we figure out how to promote and do it. The vast majority of content on Craigslist is free postings. Someone might have lost a posting, they'll repost it. As a practical matter. Obviously we don't think that's ideal. Now, someone asked earlier in the presentation about when I post a new posting, does it go to the database right away or does it sit in cache first? One of our goals is to actually get to a point where a posting can sort of be in progress in a mirrored like memcache pool. And until the posting is finalized, we don't even write it to the database. So the idea is if your posting got written to the database and you're using semi-sync replication, we're not going to lose it. Like if you got the response back in your browser that says, thanks, we've got your posting, then it means we've really got your posting. That's kind of the direction we're heading in. Yes?
There was a previous question about DDL. You may have answered it, but I don't
Oh,
think you did.
yes, the DDL question. How do we handle schema changes? We avoid them. Just like everyone else, right? Yeah, the answer is we really don't do a lot of schema changes. And I'm joking when I say we avoid them. The reality is, unlike a lot of companies, our application has been around a long time. It's fairly mature. It doesn't change a lot. So most of the time, if we're going to make a schema change, we do 2, maybe 3 things. 1, we plan it well in advance. 2, we think of all other possible schema changes we might want to roll in at the same time. So we basically take the pain once. And 3, we figure out if there's a way we can roll it out progressively, which means make it on a slave, make it on another slave, make it on another slave, and just keep doing that until all that's left is the master, and then we just swap. And swapping is easy for us now, relatively speaking. If it can't be done easily, if it's the sort of thing that's going to introduce an incompatibility where replication is going to laugh at us if we try that, and we've done this before too, then what we basically have to do is we have to say, okay, we need either some spare hardware in here, because what we're going to do is do it to a slave and then clone another slave and clone another slave and just keep those guys out of service to the point that we've got a critical mass that we can flip over to all the new slaves and a new master, presumably. We've done that in the past as well. The fact that there are tools out there now for online schema change is really encouraging. Have we tried them? No. Do we want to try them? Yeah, because I think it'd be nice to just make all that work go away if we ever need to do a schema change and just basically run a tool on autopilot. That'd be great. Yes?
I've noticed that some Craigslist postings, like, okay, date ads, pictures attached to them. Are those pictures their own, like, file system store, or do you actually encode them to?
So the question is, do Craigslist postings that have pictures on them, are those pictures stored in the database? No, they are part of the infrastructure I described here as image storage. So they're stored in the replicated across 3 nodes of this XFS on top of a bunch of disks, basically.
I have a follow-up question on
Yes.
DDL. What's your strategy for coordinating the code changes with the DDL?
Coordinating the code changes with the DDL. There's no particular strategy there. We're a particularly small shop, which means the number of software engineers you can count on 2 hands. So the way we coordinate that is by talking to each other. There's no real fancy scheme we've got for doing that. It's just we plan it all out. And we've got a technique now for having sort of a rollback branch available if we make a code change, and like a significant code change, and it blows up on us. With a significant schema change that has a code change with it, we're likely to make the change in our development environment, do a bunch of testing there, or fire up a VM and do the testing there. And then after enough people have looked at it, we're convinced it's okay, we'll make the change live. But there is some degree of, I hope this works,
Do you have some sense of sensing a version and having both old and new support in the code at the same time?
So that's a good question. Do we have a sense of like sensing a version of the data or the row that gets read and behaving based on that? A couple of our systems do something like that. Nothing I've described here, none of the really big stuff does any sort of versioning. We've tossed the idea around a few times, and I suspect we'll do something like that when one of these days we need to restructure the schema of our main database because it's kind of silly right now. And we may bite the bullet at that point and just say, you know what, not only are we going to restructure the schema, we're going to do some versioning, some other future proofing that we just never got around to. Yeah?
The code that's talking to all the databases there,
Mm-hmm.
since it is so mature, you maintain it with SVN, with Git, with...
So what's our code repository? We're using Git. We used CVS up until a couple of years ago and finally made the move to Git. Yes?
How about version configuration management, rather?
Oh, configuration management. That's a good question, too. We have, for things that are fairly static config files like proxy configs, they're just stored in Git, edited by developers or systems administrators, and then rolled out as necessary. For larger scale distributing stuff to machines and all that kind of stuff, we have our own homegrown system for doing that. We've got a series of tools that know how to do things like provision a machine, bring it up. We assign it to a particular build type in our build system, and then all the right packages get assigned to it. We don't have Puppet or Chef or any of those things. Our sysadmins in various roles have used them in the past, but partly we had our own needs, and partly there were bits of the system that existed before, and it's kind of grown organically over the years into a system that works really well, but works really well for us. We've joked internally, hey, we should open source this, and it's like, what good would it do anyone else? They don't have all the rest of our infrastructure. So it's one of those things that's tightly woven in our infrastructure. The same is true of actually of our monitoring, internal monitoring and alerting tools. They work pretty well for what we want to do, really well in most cases. It'd be cool if we could give them away and show other people, but again, it's very integrated into our database, our asset database, and our workflow right now, so it's like we can't really do that, which is good for us because it does what we want, but it sucks for us because when someone comes out with a great module to check health on a MongoDB server or monitor Sphinx or pull stuff out of the performance schema from MySQL, we can't just plug it into an Nagios instance because we don't have one. So we'd have to figure out a way to rewrite the code or use the same code into our tools. So it's kind of a double-edged sword. Way over there. Have we contributed back to the open source community? Yes, we have. We have contributed fixes to Sphinx. We have contributed fixes and enhancements to a piece of software most people haven't heard of called Haraka, which is a Node.js SMTP proxy that we're now using. We've made recently, I think it was late last year, made a sizable donation to the Perl Foundation for the ongoing maintenance and development of Perl. And we have done I've also contributed some fixes and done some testing on versions of Redis while they're in development. There's probably other stuff I'm forgetting, but the general answer is yes, we're very open source friendly. Virtually all of our infrastructure is open source, except for like internal billing tools as far as I know. But either we're running, you saw the list of software up here earlier, and there's virtually no proprietary stuff in our stack right now. Yes?
Is your master promotion tool available?
My master promotion tool is not available. I would be happy to make it available on 2 conditions. One is that we test that it works, at least once. The second is that I have to abstract away a couple things that talk to our internal asset management system to find out lists of possible hosts that are available. It's not the most elegant thing in the world, but that's okay. Yes? Okay, so the question was, how do we restart HA proxy? I'll come back to you here. And what happens to active connections? So HA proxy has 2 ways in which it can be restarted. These are both documented in the HA proxy docs. You can do a graceful restart, which what it does is, in a graceful restart, you don't want to drop existing connections. So you've got a running HA proxy process. The graceful restart brings up a second HA proxy process. That second one tells the first one, hey, give up the listening socket, I'll take it. He gives it up, he listens, so all the existing connections keep running here until they die off and this guy goes away. This one's taking all new connections. So we've got 2 modes we can restart HA proxy. One is the graceful mode, and the other one we call it the cleanup mode. So the guy here that was lingering with the old connections, sometimes it lingers for a long time. We go through and clean those up once in a while. But there is a more aggressive way, which is just killed off and restart it. But we try to avoid that because that defeats the purpose of having it there. And there was a middle guy here.
Would you expect an outage when your master fails, or would you be able to rely several minutes on your caching systems and other NoSQL solutions?
So if the master fails, what do we do? If the master fails and we don't realize it, like we don't realize it enough to put the site into a read-only mode or something like that, what happens is certain operations on the site will basically spit an error message back to the user. It'll say something's wrong, blah, 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 and then the reality is our notification system picks it up pretty quickly. All our graphs start to look really funny in a hurry, and we generally, unless it's the total middle of the night, we generally catch that pretty fast. But we don't have an automated mechanism that says, hey, looks like the master's dead, let's throw the site into read-only mode. And the reason is because until about 2 weeks ago, we didn't have a good programmatic way of quickly putting the site into read-only mode. We've just deployed one. So theoretically, we could get more aggressive about it and have certain alerts actually trigger that mode if we're confident in them. Yes? How often has the master failed in the past 12 months? 12 months, huh? Probably twice. And once is because I killed it. So really once. I found a bug, actually. I tickled a bug in MySQL that I didn't know was there. I did like a, I don't remember what it was. I think it ran an alter table that I thought wouldn't take too long. And it didn't take too long, but as soon as the alter table finished, the server crashed. We upgraded MySQL not long after that. But yeah, realistically, it doesn't happen that frequently. What happened, the biggest problem we had in our database tier for most of the last year was not server crashes due to hardware problems or anything, or MySQL problems. It was, how many of you know of this funny bug in the Linux kernel where after 207 days, so you know what I'm talking about. So there was this funny bug where like high uptime machines would just sporadically lock up after they've been up too long, which is like the most counterintuitive thing ever, right? Like you'd expect the unstable boxes to be behaving badly. So that really, a lot of our database servers have uptimes less than 100 days now because we've had to go through this process of identify all the boxes, get a patch kernel on them, and then reboot them in a very orderly fashion. So we've been doing kernel upgrades a lot in our database tier in the past few months. But that's been the most disruptive thing lately, honestly. Yes?
SSL sessions to MySQL, like for payment processing?
SSL sessions to MySQL, we don't do any of that. The actual payment processing stuff happens in its own equipment, in its own secure cage in our environment with its own security requirements around it, firewalled off from the rest of the infrastructure. And actually the communication between the web server and the database server in that case never leaves that secure cage. So, yes?
So your working set is rolling off old postings continuously, right? And don't your Innodb files have a lot of fragmentation?
So the question is, since we have a frequently churned data set, in fact, the half-life of a posting on Craigslist is short. I checked it one time a couple of years ago for a talk, and it was like 10 or 14 days or something. So our data set kind of turns itself over pretty frequently. Don't we end up with issues with Innodb fragmentation? And the answer is yeah, we do. Back when we were on spinny disks, we had to schedule sort of twice a year, roughly. One of our systems administrators would spend like a week and just defragment Innodb on a box, and then like rsync that box to another, and then the whole routine, right? Pig pain in the ass. Since we've gone to solid state storage, the fragmentation problem still exists, but we don't feel it. So we still have to do that because it'll just grow unbounded otherwise, right? Now we do it for space reasons, not necessarily performance reasons. Although in the past, it was kind of a space issue too. But yeah, it's a problem, and it's something that, it'd be nice if there was a good, elegant solution to. And we've not looked hard for one. We've not tried to develop one. It's just, since it happens now once or twice a year, it's not too high on the radar, I guess. Yes?
Any encryption or rest for the finance data?
Is there encryption involved in the finance data?
Encryption and rest, so encrypting the data on the finance data.
Are we encrypting the data on the finance side? I don't know the innards of our finance system well enough to give you an answer on how it's stored and how it's protected. And if I did, I probably wouldn't do so in a public talk. But no, honestly, I'm fairly ignorant of it. It's pretty well firewalled off from the rest of our systems. There are only a few people allowed to touch it, only a few people allowed to write code for it. And the code has to go through multiple levels of review and get signed and all sorts of crazy things in order to get on there. So I just tend not to deal with it. Was there another hand? Yes?
Have you evaluated just off-the-shelf commodity SSDs instead of Fusion IO cards?
Have we evaluated commodity SSDs versus Fusion IO cards? That's a good question, because I was going to mention that earlier when someone joked about the cost of Fusion IO. So the interesting thing is Fusion IO cards, back when we bought our first batch, were kind of the only game in town to get that kind of performance and reliability. The world has changed a lot in the last couple of years for SSDs. You look at the numbers now that are coming out of some of the SSDs that you see from was Intel, and there were two other vendors that were looking really good in terms of performance and reliability. I mean, you're seeing 40,000 IOPS or more out of a little tiny SSD with a SATA interface on it, right? We have looked at some of, not the current, but the previous generation, and we've got a couple boxes that are running sort of a RAID 0 array of some older SSDs in them. And honestly, they would probably work fine for a lot of our workloads. I don't know what the future holds for us in terms of hardware. the way the sort of consumer and the low-end enterprise, like non-PCI Express SSDs are going. It could be that a lot of our stuff could shift that direction someday. I don't know. You know, the big advantage you get out of the PCI Express type, the PCI cards is just the bandwidth you can get to and from the cards. But the biggest benefit for our kind of workload comes from the seek time going to effectively 0. The fact that you can do so many random IOPS is the big deal for us. It's just that back then you couldn't get something that had the right footprint, had the reliability, and was just, you know, it was going to do what we needed to do. So back then, it was a couple of years ago, Fusion IO was the only game in town. Since then, the other vendors are making cards that are similar, and like I said, the disk in a box SATA SSDs are much better than they used to be. Yes.
Approximately how many hardware systems do you guys have, and how many
physical systems do we have? How many sysadmins do we have? And how many employees do we have? I don't know how many physical machines we have. I'm trying to remember. It's under 1,000. Maybe it's, I don't know, 500. It's been a while since I looked, and it's hard to give an answer because we've always got machines in the state of about to be retired and new hardware coming online. We tend to refresh hardware periodically. We're actually seeing a big consolidation effect happening right now because we're going to these, you know, these new blades we're getting in have 72 gigs of RAM, you know, 24 cores, and, you know, solid-state disks in them. They can do the work of, you know, half a dozen of our previous generation hardware. So the number of physical systems is probably declining if we continue on this trend. We've got around 40 employees total, I think, something in that ballpark. I don't keep good track, but it's not a lot. And the systems administration team is, I don't know, 8. I could count them off in my head, I suppose, but it's like 8 people or so.
Do they also take care of the office side?
Yes, they do operational stuff, systems administration, all that stuff. This includes the network.
How long do you keep the hardware before you get rid of it?
How long do we keep the hardware before we get rid of it? It depends. We've got some pretty old stuff sitting in the racks still in a few places. You know, I'd say if I had to guess, on average, it's probably 3 years, maybe 2.5 in some cases. Some stuff lives a lot longer for whatever reason. Some stuff cycles a lot faster. You know, new hardware comes in and we put it where it's most needed. So sometimes stuff gets moved around a lot quicker. What do we do with the old hardware? Gosh, I don't know. Demagnetize the disks, hit them with a shotgun, and then donate it? I'm not sure. I think what we do is we find folks who deal with e-waste stuff, and we contract with one of them to take away the hardware. We generally pull all the disks, though. I know that, and the disks get some special treatment.
Is there a particular brand you're using?
Is there a particular brand we're using? What we've learned over the last N years is that all vendors suck in different ways. So, you know, no, there's not a particular. I mean, there are particular brands we're currently using, but you know, we don't have some crazy brand loyalty either. Most of our current gear is HP and IBM, but in the past it's been Rackable, and before that it was I'm trying to remember the name, but Supermicro and other places. So it's, you know, it varies. It's all commodity stuff, you know, nothing high-end, crazy, fancy. Yes. So do we run the latest version of Linux, or do we hold back a few versions? The answer to that is really mixed. On the operating system itself, we're like out of date. We generally, we're an OpenSUSE shop. We're running 11.1, if any of you guys know how old that is. But we're running like 3.1 or 3.2 kernels in a lot of places. So it's a real mix. It's like the base OS is fine for what we need. Generally, what we're upgrading is our own code base or packages that we build ourselves. You know, the HA proxy thing we do ourselves. I build my own Sphinx packages. MySQL, we download what's available. So it's a mix. You know, we're relying on the vendor for the base OS. Kernel upgrades we do as needed because of the stupid uptime bug or other weirdness we run into. Yeah, way in the back.
Wondering about how many slides are left.
That's a damn good question. All right, you all stop asking questions for a while. Let me get done. I'll go fast. How about that? So why do we use MySQL? In many cases, it's the devil we know. We're good at it. We've been at it a long time. It's got all the benefits that we all know and love, right? Durability, replication, support's all there. And the ecosystem is healthier than it's ever been, if you ask me. Memcache, It's fast, it's stable, it's been around forever, we all know it. And like I mentioned earlier, it easily coexists with the CPU-intensive stuff. So you've got a really spinny CPU process on the box, a lot of spare memory, stick a memcache on there, you're better utilizing the box. Easy. What do we use it for at Craigslist? This is kind of repeaty, so I'll go fast. Primary cache for rendered pages, both compressed and full size on the proxies. Lots of internal caching of various objects and things like that. We have a custom async library in Perl that talks to it, so our requests parallelize very well. We had some key encoding issues at one point, which was the downside of writing our own library for that, but that's been fixed. We do get some level of durability out of it because we actually do sort of a client-side mirroring type thing. You can think of it as like a RAID 1 in memcache, where all keys get written to two halves of a mirror. So that gives us some reliability against machine failure. Redis, I talked about this. Someone asked. This is kind of a repository of activity about posting metadata and activity going on the site. Won't get into a lot of detail on what that really is, but it's useful for tracking stuff. A vast majority of our data is stored in Z sets, which are sorted sets. So you can put items into a set where the uniqueness on the items is enforced, and the items are sorted based on a value that is inserted along with them. It's sort of a sharded multi-node cluster, and this link, you can search for Redis sharding Craigslist, and you'll find some blog post that describes how we do that. Why do we use it? It's got that right mix of features I talked about, all the scripting type data structures available on the network, so it's fast. It's got a really nice API. It's very, very simple to pick up and use. You'd be there in less than a day. It's very predictable. It's kind of like once you know part of it, the other parts of it fall into place naturally. The general project vision for it's been really good. The maintainers and developers have been really good about keeping a fairly narrow focus and only adding in the most essential things so it doesn't get lots of crazy creep. And works great in multi-core boxes with lots of instances. MongoDB, this is our repository of archive postings. So once postings are old enough, they are migrated out of the Craigslist CLDB, we call it, or Craigslist postings database, which is MySQL, into MongoDB. We've got over 2.5 billion postings in there, and that grows with time. We just keep adding to it. We've got the data sharded across 3 MongoDB replica sets. If any of you have used MongoDB, that may make some sense to you. But basically that means we've got 3 machine clusters and a third of the data is on each, and MongoDB takes care of the sharding for us. We've got and this is all duplicated in a second data center. We've got about 6 terabytes of data in there currently, and we're sized the cluster to go to about double that, which is about 5 billion postings or 12 terabytes. The biggest fun I had with this was the data migration. There are 2 talks available on the MongoDB, Tengen MongoDB website where I talk about this project in much, much more detail. One was before we did the project. It's like, hey, I think I'm going to use Mongo for this. Here's why. And then a year later I came back and I was like, hey, I did it. Here's what I learned, which was all, was interesting. So this is the before talk and the after talk, easily searchable, or you can find them on the Tengen website. Why are we using it along with MySQL for some stuff? Well, the fact that it's a schemaless system, it's a document store, matters a lot. If we're going to keep postings around for a long, long time, we can't be doing alter tables on many, many terabytes of data because that used to take a long time. Imagine running alter table on your master. It takes a month, and then the slaves take another month to do it. That's what we replaced with Mongo. It's got a great community behind it. It's got a good company behind it. This was another big thing. A lot of the data stores I looked at didn't have a Perl client because Perl's not a fancy, sexy web language these days. But that's what we use, so that mattered. And scaling, easy scaling was a big deal for us too. We got sick of having to tear down MySQL servers, rip out all the 600 gig disks, put in 900 gig disks, and bring it back up and put all the data back on there because that was the only option we had. I'll get your question in 1 sec. And the built-in sharding support was awesome. I mean, it was like, this is a no-brainer. It's like once you saw the feature set, it's like, this is what we need. The fact that it's got built-in sharding and the replica sets mean there are fewer single points of failure. You can walk up with a shotgun, hit a machine, and then the thing just keeps running. If it was the master, no big deal. The machine takes over, keeps running. That's been great for us. Your question?
When you're talking about this as using that for the archiving, what about since separately you have the images on the file system? You just leave those as is and don't worry about it?
So what do we do about images with archiving? Old images just vanish. We don't archive the images. That's the easy answer. Yes?
What version of MongoDB are you running, and how easy was it to start charting?
What version of MongoDB are we running? We're running 2.0 in our standby data center, 1.8 in our active data center. We're a couple of weeks away from flipping to the other data center because we're finishing maintenance in the standby data center. When we do, we're going to upgrade the other one to 2.0 as well. The charting was easy because we did it from the get-go. We didn't graft it on later. One of the things I talk about in that second talk is one trick I learned is something called pre-splitting in the data. You pre-split the data chunks, and the loading of all that data in goes dramatically faster. I talk about that also in a blog post as well. Yes?
Can you derive any value for your MongoDB by using SSDs if you're not using them right now?
So MongoDB, what if we use SSDs? We don't read much from this cluster, so no. This is kind of warm storage. The number of times a day someone comes in and pulls up an old posting pales in comparison to everything else we do. So we could be using consumer SATA disks here and it wouldn't matter. Or it's not a high volume system. I talked about Sphinx. How many of you have heard of Sphinx for search? Oh God, a lot more than I expected. That's great. So we use it for all sorts of full text search. All of our live postings are in a Sphinx cluster. All of our archive postings are in a whole other Sphinx cluster. All of our forms, no longer in progress. I finished that, so that's done. We're doing well over 300 million daily queries with Sphinx on our backend servers. Someone asked about Solar, Lucene. I looked at options 3 years ago when I started this project to get rid of MySQL full text. At the time, Sphinx was the right combination of approachable for me without a lot of other Java bloat and things that came with it. It sort of felt like it fit that philosophy as one tool that does one thing well. It's basically like a single binary config file, and I could script all the other stuff around it I needed to. And in the performance testing I did at the time when I ran it against Solar, Solar did well Lucene, or was it Solar? I looked at one of the two. Did very well in most cases. Sphinx did well in the same cases, but when you got to the edges, it started to fall down, and Sphinx was much tighter in there.
How do you evaluate their abilities for full text search? Is that a deciding factor, or just something other?
The deciding factor was not the completeness of, it wasn't the feature set of the full text search, because we were coming from MySQL full text, so our requirements were not that big, right? We just wanted something that worked and didn't fall down all the time, requiring repair table. So we didn't need a lot of really crazy fancy things. The great news is that as we've used Sphinx more, as a product, it has matured, and they've added a lot of the features that we might have looked for back then if we had a grander vision of what we wanted to do. But at the time, it was really just, this thing's bleeding, we need to fix it. So a lot of new features have come into it that we've actually taken advantage of, or some of them are there because we requested and or paid for them. But we've been really, really happy with it. I don't have anything negative to say about Lucene or Solar. I know tons of people who have done great stuff with them as well, and they work well. So, to me, it's just like pick the one you like because they're all very capable. Yes? Are we using real-time indexing in Sphinx? Not for any of this stuff, but I am testing real-time indexing in one deployment, and I did a presentation about this at the Sphinx user conference recently. So I'm testing it out to see how it runs in our environment. I'm using it for a short term, like last couple days worth of postings, sort of to kind of fill the gap between like not real time and all the stuff that we're actually indexing. So it's working pretty well. We have not put substantial load on it yet, so it's hard to say. Yes, over there. What's that? How we handle delta indexes, we actually use the sort of main plus delta scheme described in the Sphinx manual. I could go into a lot more detail on that later on, maybe if people are interested, because I know it's getting a little late. Plus, I actually have a talk online that if you look around, you'll find too, where I explain this as well. I'm going to keep going. So why Sphinx? Performance is really good. Had a friendly API. It's actually gotten better because now you can speak to it over the MySQL protocol and fire SQL-like queries at it. It was very flexible. We could deploy it the way we wanted it to because it's sort of like having a couple small tools you can piece together however you want. So it worked very well in the way we wanted to deploy it. And the fact that we could get commercial support for it was helpful as well. It does a great service for us, so we're more than happy to contribute to its future development. I talked about having a file system. As I mentioned before, uploaded images are stored in the file system, multiple sizes stored on disk. They're cached out in the front end. I can't say a lot more about this other than, it does the job really well. There's no sense going to a fancy database or something else like that. We could use GridFS and MongoDB, or we could store it in MySQL, or we could do all sorts of other stuff, but it's just, that's all overkill, which is kind of what I just said. So, okay. So we've got all these data stores, right? The downside of this is, for us with a mature code base, and by mature I mean messy, it can be tricky because we've got different developers there who know different parts of the system, and not everyone wants to learn a new data store every year. I do that for whatever reason, but I'm crazy. So what we had to do internally is we built out our own abstraction layer. That way, if we were going to go and have to touch code because it's no longer in MySQL, now it's in Mongo, for example, we figured if we're going to go touch that code, we're going to touch it once. So we built an abstraction layer where you can write queries, and it hides the details of the exact indexer used to find the data and the exact storage engine to fetch it from. So we've abstracted a lot of that away so that in the future we can make more back-end changes without having to go in and alter code again. So that took many, many months of design and work to develop, and it's still sort of a work in progress. It does the core function, it has the core functionality we need, but we're always thinking of more things we can add to it over time. People always ask the question of relational or non-relational. It's like, practically speaking, for a lot of what we do, we don't care. It just has to work. Much of our data is not relational by nature, but we're using a relational database for it because it's a mature product, because we understand it, because we can predict how it's going to behave, we know how to support it. The flip side of that is it gives us pain sometimes because of schema changes and stuff like that. So, we've got a mix of things out there. I think the whole NoSQL thing is a stupid label. It's just, the query language is not what makes the difference here. It would be great if we had the same query language for everything, which is why we had to build our own system internally for that. So I covered some of this stuff, but I know people always ask these things. Told you we're not doing virtualization or cloud stuff. We're self-hosted. We've got a mix of hardware. It's almost all local storage. We only use a SAN for backups and a couple other non-critical. Well, backups are critical, but I mean other non-user-facing things. Virtually all open source, like I mentioned. I say virtually, and I can't think of a closed source thing in our infrastructure, so I should just say open source infrastructure. And we do have a very small but growing tech team, which leads me to my last slide. At least I can be the last one tonight to say we're hiring. Letter Z at Craigslist.org if you want to send me a resume in plain text or come find me later on. Otherwise, I'm happy to either take more questions or let Erin do her thing with the raffle. What are you cool with? Do you want to do?
It's a little late.
Okay.
So, and there's so many of you guys. We do have a hard, we got to get out of here by 9:30. So why don't we do? Oh, sorry. I guess I'm used to a smaller house. So I think we have a hard limit. We have to be out of here by 9:30. They will start rounding us up at about 9:15. So why don't we go ahead and do the raffle and then break out into smaller groups. I think there are probably people that didn't get a raffle ticket. And you should come up here. I'm not going to run around. I already did that. Oh my God, there's that many of you.
Well, you're giving me the winning ticket, right?
Talk to the computer. So, Jeremy, I'm sorry I just sort of went into this. But we'll bring him back. I'm not going to have the last word. Yeah. Keep this coupon. You keep that. So I take it a lot of you are first-timers, because those of you that have been before know we always raffle off something. And tonight we have, thank goodness that Vadim is here. He brought 2 of the new Percona's MySQL high-performance books. We have some T-shirts, and of course, Jeremy's going to be involved in the Craigslist. Yeah. Oh my goodness. And then give the last number to Mike.
Oh, you didn't get one?
No, he gets the last number.
Whatever the last number that hasn't been assigned yet.
That's okay.
I get the highest number.
He gets the highest number. So we have a computer that's going to generate stuff, and my co-host Mike is going to do that. I think there are about 6 or 7 tickets that did not find a home. So we expect some of those numbers will not have somebody. So I'd like to start with the book. It is not signed, unfortunately, because Vadim did not want to ruin the pretty new book. I told him we would have liked to have had it signed, so maybe the next time I can twist his arm to bring signed books. So it looks like the first person, and they win a book.
599. Wait a second. Hold on here. Yes, 599, 601.
Start with 1.
599. Yeah. 601. Already gone. 605. They're not sequential.
Oh, wait, we got a winner in the back.
They look sequential. Yeah.
Well, we all know how random
This is why you shouldn't use order by rand.
Yeah. 607.
607. We're raffling off a T-shirt.
All right. So here's where it goes non-random. Back to 583. 582. See, reverse order this time. We have like 2 sizes of stuff. 582. 582, anyone? 590? Woohoo! Keep it. 5. Did I hear a yes on 590? Okay, there we go. 596. Well, you had 2 things in your hand. 590 was first. One more. 589. 604. 600. 603. Oh, we got 600. Yes, I did 604. Oh, bummer. No 600? All right, 603? You know what? I can't help what it pulls out here. Random.org.
Okay, wait, don't. Now we're going to bring Jeremy over here. I know he's deep in conversation.
Oh, sure. So one of the ways Craigslist is a little we're always looking out for things we can do to help out the community and give back. And what we decided to do tonight, instead of like giving away an iPad or something like that, because everyone's got fancy toys, is we will give the winner